Welcome back. In the last video, we learned how to store information using variables and different data types. Now that we have our data, we need ways to perform actions on it. That's where operators come into play. In this video, we will practice working with variables and also explore various types of operators in Java, including arithmetic, relational, and logical operators. We will also learn about operator precedence and how to write and evaluate expressions. My name is Oleg, it's DevNight, let's get started.
Okay, let's get back to our IDE and learn how to use the three types of operators in Java. Let's start with a little note to ourselves so we can easily refer back to it later and see what we haven't done yet. As I mentioned, we're going to look at three types of operators in Java: arithmetic operators, comparison operators, and logical operators. Let's start with arithmetic operators. And in Java, we have the following arithmetic operators: addition, subtraction, multiplication, division, modulus, increment, and decrement. We'll go through all of these in detail now, and then we'll move on to the other types of operators. To give us something to work with, let's set up some variables. For example, int x equals 100, int y equals 5, and int z equals 10. And for a bit of variety, let's make one variable of type double, d, with a value of 3.0. So now that we have our variables, we can perform arithmetic operations with them. Since they are numbers, we can perform mathematical operations with them, and that's possible in programming too. Let's start with addition. Let's say we want to add the value of variable y to the value of variable x. To do that, we simply write x plus y and put a semicolon at the end. That means we've completed our statement. But this alone isn't enough, because the act of adding gives us some result. So we need to create a new variable. Let's call it sum. And using the assignment operator, we'll store the result of adding x and y into it. This is how we perform addition in Java. It will take the value of the variable x, which is 100, the value of the variable y, which is 5, and the result of adding 100 plus 5 will be stored in the variable sum. We can then use this variable as we need. For example, let's print it to the console. By the way, instead of typing out this long command system.out.println, we can use a shortcut. Type SOUT and press enter, and the IDE will write the long command for us. But that's not important. Let's see what gets printed to the console after we use the addition operator. And as we can see, 105 was printed, which means our addition worked correctly. We can do addition in exactly the same way, without any variables at all. Just add any two numbers we have in our heads. Let's create a variable called sum1, and let's put 10 plus 11 into it and print it to the console. Now sum1, not sum. Let's run it, and we can see that it works just as well. We can mix both these approaches using variable names and literal values at the same time. Let's create another variable, sum2, and write, for example, z plus 100, and print this variable to the console. And we get 110, which is exactly right. So we can use addition however we like. We can use variable names, literal values, or mix both approaches. We can also use multiple addition operators in a single expression. For instance, if we need to add 3 numbers or more, we can keep writing. For example, let's add the value of the variable x as well. And in this case, these operations will be performed sequentially. First, 100 is added to z, then the result is added to x. Let's run it and see that everything works. Z was 10, then we added 100, and then we added x, which is 100. I think that's all clear. It's not too hard to figure out. And in fact, all the other basic operations, like subtraction, multiplication, and division, work pretty much the same way. Let's create a new variable called subtraction, and let's put the value of x minus y into it. Let's try to print it and see that everything is working correctly. 95. 100 minus 5 is 95. All good. In the same way, and I won't spell out all the same examples here, it's pretty clear that the same thing works for subtraction. Plus, you can mix pluses and pluses again. There's no difference. For clarity, let's also use multiplication. Let's create a new variable called multiplication for that. And let's say we want to multiply y by z. So we use an asterisk for multiplication, a minus sign for subtraction, a plus sign for addition, and a slash for division. What's important to note here? As you might have noticed, the result of each operation is an integer, and it's a whole number precisely because our initial variables, x, y, and z, are of type int. So, the result of addition, subtraction, and multiplication will also be an int. But what if one of our variables is of type double? We have a variable d here which is 3.0. What if we want to add it to our int variable? What would happen? Let's see. Let's change x here to d. And we see that the IDE is underlining it in red. This means there's some kind of error. The error is that when you add, subtract, multiply, or divide an int and a double, the result will always be a double. Therefore, the variable sum will now be a double, not an int. Why is this happening? Because double variables can store integers, but int variables can't store decimal numbers. Therefore, when we mix an integer and a decimal number, Java always converts everything to a decimal number. Let's print the result to the console and see that the result will now be a decimal number. Yes, the presence of the dot indicates that the type of the result is a double, that is, a decimal number. The same goes for subtraction and multiplication. If one of the variables is of type double, the result will automatically become a double too. Next, we haven't looked at division at all, as there are nuances here. Let's make another variable of type int. Let's call it division and say we want to divide x by y, and let's print it and see what happens. And we got 20. Our initial variables were 105. 100 divided by 5 is 20. But what if the result of the division isn't a whole number? I mean, 100 divided by 5 has no remainder. But what if the variable y were, for example, 3? 100 divided by 3 isn't a whole number. What do we get as a result? Let's check. We divide x by y, 100 by 3, and in the answer, we get 33. So as you can see, we just ignore the whole decimal part, everything after the dot. We ignore it because, again, our type is an integer, and therefore integers in Java cannot store any values after the decimal point. But in this case, the result of the division is inaccurate. We can't get 33 by dividing 100 by 3. It will be 33 and 3 repeating. So it's recommended to use the double type for division to not lose this decimal part. It will not add any accuracy to our calculations. Let's run it. Check and see that as the result was 33, it remained 33. Just now, it's 33 in decimal form. Therefore, for the result to be accurate, at least one of the variables participating in the expression must be of type double. Then the result will be correct, exactly 1. Not necessarily 2, but at least 1. Let's go up. Well, we already have a double type variable here with a value of 3, so instead of y, I will just write the variable d in the expression. And thus we see an absolutely accurate result for division, or accurate to a degree that double type allows it to preserve, that it's not infinite, that it can't store an infinite number of 3s. But for most cases, I think this result is quite sufficient. So yeah, once again, it's important to remember that to get accurate division results, at least one of the variables in the operation must be of type double. Then the result of the double type will store the exact value. This is just a nuance that you always need to remember. And the last arithmetic operator we have left is the modulo, or remainder operator. Let's create a new variable. Let's call it remainder, and let's put the remainder of x divided by y into it. As far as I remember, x was 100 and y is 3. So 100 divided by 3 doesn't divide without a remainder. Let's see what remainder we get. So this percentage sign is just a way of denoting that the result will be the remainder. The operation itself is called the remainder operator. Let's run it, and we can see that the remainder is 1. The only thing that might confuse you here is the use of the percentage sign, but it's not a percentage. It's the remainder of dividing one number by another. And I almost forgot, it's not the last operator. We have two more interesting operators here. If you're not familiar with programming, they might seem pretty strange to you. Those are two pluses and two minuses, increment and decrement. Let's take a look at them. To make it convenient for us, I suggest that we move the values of these variables closer to where we will be programming, but we won't define them anew since we already have them. Variables x, y, and z. We'll just reset their values like this. So we'll reassign their values. It's just for convenience, so we don't have to constantly go back up there. So let's start with the syntax. Let's say we have a variable z equal to 10. we can use two plus signs to increment this variable. What does increment mean? It means we add 1 to it. That's all. Increment means add 1 to the current value. And that's all, no other actions. Unlike other operators, the result of an increment or decrement, which is minus minus by the way, the result will be minus 1, 10 minus 1, which will be 9 after the execution of this operation. In the case of the plus sign, the result will be plus 1. So it's not necessary to save the result of this operation to a separate variable because this operator changes our original variable. If in the case of ordinary operators, our initial variables, for example x and d here, they did not change, the result was written to a new variable, then increment and decrement change our initial variable. Well, let's put z dash dash here for an example. What actually happens when we write such an operation? Let me put one more comment block here. When we call an operation, for example, increment, this happens behind the scenes. We create a temporary variable, let's call it temp, the result of adding the initial. Then, the result of this addition is assigned to our initial variable z. So, when we call such an operation z the plus plus once, two operations are essentially performed, which are combined for our convenience into this shorthand notation. So, we create a new variable with a result that is one more than our initial value, and our initial variable is overwritten with a new value. That's all. The same thing happens with the decrement when we do minus 1. The difference between increment and decrement is that in the first case, 1 is added, in the second case, 1 is subtracted. That's all. Let's remove the decrement for now and try to print our variable z. And let's see. And now we see that 11 is printed. So by calling this operator once, we increase the value of the initial variable by 1. Let's do the decrement again, and now the value of the variable should return to 10. It's 10, all good. There are two ways to write increment and decrement. This way we tried is called postfix. It means that our operators plus plus and minus minus go after the name of our variable. But there's also a prefix way of writing it, where the plus signs come before the variable, or the minus signs come before the variable. What's the difference? Let's comment this out so it won't get in our way. Let's comment this too so we have only one operation. Initially, our variable was 10. Now we do plus plus z, print it, and see that the result is again 11. So there's no difference with the postfix notation. There actually is, but we didn't see this difference in our example. The same thing, if we do z, run it again, the variable will return to 10, just like in this case. But what's the difference between the postfix and prefix notation? It's small, but it still exists. Let's imagine that we want to perform the increment or decrement operation not as a separate action, not on its own separate line, but we need to do it only once and in the place where we want to see this result. For example, if we just need to increase our variable by 1, we can just write this notation right in our system.out.println. Let's comment it out so it won't be considered when the code is executed. And let's see what happens. So we are essentially doing the same thing. We are increasing the variable by 1, but instead of doing it as a separate action on a separate line, we immediately pass it to where we want to use it. That is, we want to print the value of variable z increased by 1. Let's run it and see. 11. Everything is working as we expected. The value of the variable increased by 1, and the new result was printed to the console. But if we return to the postfix notation, let's write z++ here and try it again. We see that the value of the variable hasn't changed. This is where the difference actually lies. When we wrote the increment as a separate action on its own line, when our code was executed line by line, it reached this line, executed it, changed the value of the variable z, and then on the next line we printed the new value to the console. And then everything worked. But if we immediately pass the new value to system.out.println, without printing it separately, the value will not change because in the postfix notation of the increment and decrement, the actual change of our initial variable z happens after we pass the value to system.out.println. In this case, we are still passing the initial value. If we write it in the prefix style, then in this case, the value of the variable z will be changed first, and only then will it be printed to the console. The difference is quite small, but in some cases it can be important. Later, during the development, during the writing of your own algorithms or programs, you'll probably encounter it. But for now, if you're using increment and decrement as a separate action, then I recommend simply using the postfix notation, because then there's simply no difference in the result. Maybe it's not very clear right now, simply because you haven't seen examples of using one or another notation. Let's move on. We've gone over all the arithmetic operators in Java. Next up, we have comparison operators. Java has the following comparison operators: greater than, less than, greater than, or equal to, less than, or equal to, equals, and not equals. Let's get to grips with them. Let's go a little lower. Let's also leave this code on top and say, for example, that we want to compare the variable x with the variable y. Is variable x greater than variable y? Let's move those variables a little closer for a second so we can see them. Again, they will simply be overwritten. The previous values will all be erased. So if I want to compare whether variable x is greater than y, I need to write something like this again. One operand, the second operand, and our operator between them. Again, we cannot write this expression by itself. The result must always be saved somewhere. Only, unlike ordinary arithmetic operations, the result of our comparisons will be a boolean. Let's call it is greater. Why boolean? Because the question of whether variable x is greater than y can only be answered with yes or no, which is what the boolean type represents in Java, as it stores true or false. If the variable x is greater than y, which is true in our case, then the result of variable is greater will store the value true. Let's print it to the console and see that that's actually the case. Let's run the application and see that we have printed true, which means that the result of this expression x greater than y returned true. This value true was saved to the variable is greater, and we use the value of this variable is greater when printing to the console. Just like with arithmetic operators, we can mix the use of variable names and literal values. For example, let's use the less than operator. That was greater than. Let's use less than. Let's call the variable is less, and say that z is less than 3, semicolon. Here, we are checking whether the value of variable z is less than 3. Obviously, the answer is no, it is not less. Accordingly, the result of this expression will be false, and this false will be saved to the variable is less. Let's print it and see that we do actually print false. Yes, all good. Indeed, 10 is not less than 3. Absolutely the same rules work with other kinds of logical operators. Let's make, for example, is greater than or equal. And let's say we compare. Let's say that x is less than or equal to 100. We see that our variable x is equal to 100. And accordingly, we expect that the result will be true here, because x is indeed less than or equal to 100. Let's print it. Check it again. Yes, indeed true. In the same way, we can make is, or rather that was is less than, right? I mixed up. Is less than or equal. And this is our is. This is where we actually have is greater than or equal. And here, for example, we put x greater than or equal to. Well, let's just say we'll do y. Let's print it. Yes, indeed, the value of our variable x is greater than or equal to the value of our variable y. Next, the next comparison operator. How can we compare whether two values are equal to each other? Let's create a new variable. Let's call it is equal and say we are comparing z with y. Double equals. We see that we have a single equals and a double equals. It may be a little confusing, but it's important to remember that a single equals is an assignment. We are assigning some result to some variable. A double equals is a comparison. The next sentence. We are asking, is the value of the variable z equal to the value of the variable y? The result again will be true or false, and this result will be stored in the variable is equal. Let's check. Is z equal to y? Let's run it. And we see that no, it's not. And the last operator from comparison operators, let's call it is not equal. And let's put the result of comparing z and y into it, only with a negation this time. Is z not equal to y? A semicolon is required. The difference once more is between double equals and exclamation mark equals, because here we are asking is z not equal to y? So here z is not equal to y. 10 is not equal to 3. So the expression is true because z really is not equal to y. And in the variable is not equal, we'll write the result of true, because z is once again not equal to 3. Let's check. And we did indeed print true. So an exclamation mark generally simply indicates negation. Once again, I want to emphasize that a single equals sign is the assignment of a result or some value to some variable. Double equals and exclamation mark equals are comparison operators. When we ask, Is something really true? Is it true that z is equal to y, or is it true that z is not equal to y? I hope that's clear, and we can move on. Unlike ordinary arithmetic operators, we can't use multiple operators in a row in expressions of this kind. For example, we can't say x greater than y less than 10. It makes no sense. It's unclear what needs to be compared with what. Let's move on. The last type of operators that we have left is logical operators. Logical operators in Java are represented by the following: logical AND, logical OR, and logical NOT, negation. Here are some interesting things, we'll deal with them now. Two ampersands denote AND, two pipes or vertical bars denote OR, and one exclamation mark denotes, like in the case of the comparison operator, negation. That is NOT. Simply the word NOT here. Let's see in practice how this works. I'll move this code a little lower so there's some free space. And let's imagine a situation where we have three Boolean type variables in our application, which denote some things that are important for our business or for our program. For example, Boolean isAdult will store true. Boolean has ID will also be equal to, let's say, true, and Boolean signed agreement can be equal to false. Let's say we have three such variables. There are different types of applications, so you can come up with any scenario for how to use them. For example, the user has a result of the choice. Has he reached adulthood? Does he have an ID on him? And has he signed some kind of agreement? Based on these three things, we can draw some logical conclusions in our program. For example, we want to allow or disallow the user from doing something. Let's create a separate variable for this. And let's say, for example, that we want to allow the user to do something only if he is an adult and he has his ID with him. Let's write it down. So, isAllowed will be true when the user is an adult and he has an ID. It's that simple. So again, the AND operator is used in pretty much the same way as other operators. It's placed between two operands. It works in the following way. If both parts of our expression, and this is our expression, if both parts, both the left and right parts, are equal to true, then only then will the result of the whole expression be equal to true. In our case, isAllowed is true. If at least one of the operands is not equal to true, that is, it will be false, then the AND operator will return the result false. Since, again, both parts of the expression must be equal to true for the AND operator to return true. In this case, one of the operands is equal to true. The second operand is equal to false. Therefore, the result of the AND operator will be false. Let's print it and see. Yes, indeed it's false. And accordingly, if both operands are equal to false, then again, the result will be false. So again, in order to get true when using the AND operator, we need both parts of the expression to be equal to true. Both. Let's put the value back to true for both of them, and let's look at the next operator. Let's call the next variable, for example, isAllowed1. And let's say that we'll now use the operator that's called OR. I will just copy the semicolon and use two pipes to say that the result of our expression should be equal to true when our left operand is equal to true or our right operand is equal to true. In our case, both operands are equal to true, so the condition that at least one of them should be true is satisfied, and again, the result of the entire expression will be true. Let's print isAllowed1 and see that yes, it is indeed true. Unlike the AND operator, if one of the variables is equal to false, it won't change anything, because the condition is satisfied. Either the left or right variable, at least one of them, should be true. In this case, when one is false and one is true, the condition matches, so the result will be true. Let's check and see. Adding true, really. So, in what case will it be false? Well, it will only be false here when both variables are equal to false. And in this case, neither the left nor the right variable are equal to true, and therefore, the result of the entire expression will be false. This is the whole difference between the and OR operator. The AND operator will be true only when both expressions are equal to true. The OR operator will be false only when both the left and right operator are equal to false. Which of these operators to use will be dictated by the logic of our application. For example, if we need to let someone through somewhere if they are an adult and do not have an ID, then we will use or vice versa if they are not an adult but have an ID somehow. The next logical operator is the NOT operator. Let's create a new variable. Boolean is allowed to and put this result into it. Is adult, but with a negation. It is put before the name of the variable or before some value, always before. What will happen in this case? The not operator simply inverts the result of our value, which is written after it, after the exclamation mark. Now we have a variable is adult, inside of which is stored the value of false after the exclamation mark. The exclamation mark, our not, will reverse that value. It was false, it becomes true. Consequently, the variable is allowed to will store true. Let's see. Yes, indeed true. If the variable is adult had initially been equal to true, then the not operator would have turned it in the opposite direction and the result would have been false. It's also used very often and serves to implement different scenarios. For example, if we want to allow the user to do something only if they are an adult, but for example, in this case, they haven't signed the agreement. What's going to happen here? Let's go through it, since the logic is a bit more complex here. I'll make this comment and write the order of actions on top. What's going to happen and why? In this expression, this sub-expression will be evaluated first, since it also contains an operator and this is an operator exactly. The same as this one. So, to compare these two expressions, we need to evaluate this sub-expression first. Initially, the value of the variable signed agreement was false. The not operator will invert that value. So, the result of this little sub-expression will be true. Next, the variable is adult was equal to true. It remains here because we are not inverting it. Since it was true, it will remain true. Next, the AND operator will operate. We remember how it works. It will return true only when the left side and the right side, the whole side, is equal to true. In our case, the left side is true, and we already evaluated the right side, which will also be equal to true, and so the result of this entire big expression will also be equal to true. Let's check this. And indeed, we see that everything's correct. So, depending on the logic of our application, we can use these three operators to organize any logic we need. If we want variable is allowed to be true only if the variable is adult is true, has add is true, and let's say signed agreement is also true, in this case, the result of this large expression will be equal to true only if all three parameters are equal to true, and so basically indefinitely. We can add as many of these ands as we want here, and the result will be true only if everything, all the participating members here, are equal to true. The situation with OR is similar. If more than two variables participate, if at least one of them is equal to true, then the result of the entire expression will again be true. In this case, we will obviously get false because we have two variables equal to false. And here, the result of the entire expression will be true, because we have one variable that's equal to true. Things get a bit more interesting. What if we want to mix and or for example, or and not, or and or and not? Basically, we want to mix everything together. How will this all work? For this, we need to go back to our arithmetic variables a little bit, because it will be easier to understand that way, and look at how the order of operators works for our regular arithmetic operations. In Java, as in math, the order of operators is determined by their strength. That is, multiplication and division operators will have a greater strength than addition and subtraction operators. And for example, in this expression, if we want to change the order of operators, that is, how they should act, just like in math, we can just put parentheses around the places that need to be done first. For example, we wrap xd in parentheses, and in this case, the result of xd will be calculated first, and then the result will be multiplied by y. I think there's no point in going into much detail here. As in math, we surround the things in parentheses that should be executed first. So, the interesting thing is that in the case of logical operators, we can use these parentheses where we need to explicitly specify the order of operations. Because in logical operators, just like in arithmetic ones, there is its own order of operations. The AND operator will always be stronger than the OR operator. Let's check. Let's create a new variable boolean is allowed and say, for example, that it will be equal to true when is adult is true or has id is true and signed agreement is true. Now let's say that we're going to be printing this variable specifically to the console, and let's see, or at least try to predict what will happen. Our variable is adult is equal to true, so we've saved that what we're going to have here will be true. Hasid is false and signed agreement is false. So we have false here and false here. What will be executed first? And or. Let's check. Let's run it. Let's see that our result is true. And that definitely means that the AND operator was executed first, and only then was the OR executed. Since we saw the result true, it means that the last operator that was executed in any case was OR, no matter what was there next, but in any case, one, or in our case, two variables were false. And we could only get true as a result if the last operation was OR. Because, as you remember, when we use OR, we need at least something to be equal to true. Therefore, the AND operator was executed here first, and only then the OR operator. If we want to change the order of these operations, we need to wrap it in parentheses again. We're saying that we want to compare isAdult and hasId first. So we will say that we first want to calculate the result of isAdult or hasId, which will be equal to true in our case, and then use this true as the evaluation of the AND operator. We will have true here, and signed agreement was false. Accordingly, AND should return false. Let's see if anything changed. Yes, it changed. You see, we changed the order of execution of the operators and achieved the result we needed. Therefore, again, to summarize, as in arithmetic operators, in logical ones we have an order of execution of operators. The AND operator will always be a stronger operator. That is, it will be executed first and then the OR. If we want to change, we use parentheses. All of these conditions, they're sometimes quite complex. A lot of different kinds of variables are involved, so it's pretty common to actually wrap our parts of expressions in some parentheses to specify the order of operations. And the last thing I wanted to mention in this video, since our logical operators always return values of the type Boolean, and our comparison operators also return the type Boolean, we can use them together. We can mix the use of comparison and logical operators. For example, let's bring back our variables x, y, and z, these ones, a little closer here. And for example, let's say we'll have some kind of result. Let's call it result, where we'll store true if x is greater than, say, 80, or y is less than 0. I always advise separating comparison operators and logical operators with parentheses, simply for convenience, to distinguish between different types of operators. And accordingly, this expression reads as, we want to put the result true into the variable result, when the value of the expression x greater than 80 is true, or when the value of the expression I less than 0 is true. In our case, x greater than 80 will return true, and y less than 0 will return false. But since we are using the OR operator, we only need one of these two to be true, and therefore our result will be true. Let's check it. Yes, indeed, that's right. If we had used the AND operator here, then the result would be false, since the right side of the expression, y less than 0, is equal to false. Let's run it and check it one last time. Yes, false indeed. So I hope all of this was clear. If not, rewatch it again, because these kinds of operators, arithmetic, logical, and comparison operators, are used constantly as you program.
Great job! You've now learned about different types of operators in Java and how to write and evaluate expressions. Understanding operators is fundamental for writing logic and performing calculations in your programs. In the next video, we will start learning about conditional statements, which allow us to make decisions in our code based on the evaluation of expressions. Remember, you don't learn programming when you are not coding, so practice using different operators and writing various expressions. Experiment with parentheses to control the order of evaluation. If you have any questions, please leave a comment below. Don't forget to like this video and subscribe for more Java programming tutorials. See you in the next one, and happy coding!